Hello everyone, let's look at LeetCode problem number 2370, longest ideal subsequence. So as usual, this is today's POTD. So what we are given here is a string of characters. Okay, one thing to note here is that this string S contains only lower letters, lower English letters. So we can use an array of 26 characters to store the occurrences of string, or as you might have understood that this is a subsequence problem, so we also need to use DP in this problem. So we can make the DP array of only 26 characters. Okay, so now let's see the most optimal approach of this problem. You can also solve it by top down, bottom up, and then space optimize it. I'm telling you the most space optimized best solution of this problem. Okay, so we'll make a DP array of length 26 to represent each character. Okay, so let me make the DP array. Okay, so let's have look at the DP array. So as discussed, DP array will be of 26 characters. So what this DP array represent here is this DP of I represent here the length of subsequence ending at I. Okay, so length of subsequence ending at I. Now we will use a variable I to traverse the string S. Okay, so first we have I is equals to 0. I is equals to 0, so we have our current is equals to A. Okay, now we have our current is equals to A, which is S of I. Current will be S of I. For this case, these both will be 0. As to map this to DP array, we will minus the ASCII value of A from current. Okay, so now our current is A, so A minus A will give us 0. So now what we'll do is, firstly the DP array will be filled by 0. Zeros, because initially when I is not in the string that we are just starting out, then the length of such subsequence is 0. As longer length of any subsequence is 0 now. Okay, so now what we'll do is increase the length of subsequence ending at A by 1. So what we'll do is we will say DP of current plus plus. So now this will become 1. And now the crucial part is we will traverse the neighbors within range K of our current. That is, in this case we have our current as A and our K is equals to 2. So we will go 2 neighbors before it and 2 neighbors after it. Before A we have nothing, so we don't worry about it now. But after A we have B and C. So we will check B and C, and we will not check before it because it goes out of bound now. Similarly, if that was J, then we could have checked X and Y and don't go beyond that because that will be out of bound. Okay, so now let's say we are doing this by another loop inside, that is a nested loop. So our J will go from J will traverse from B and C, that is 1 and 2. So J will be here, then here. So what we will do is we will update DP of current by max of DP of current, comma the J value, the DP of J plus 1, as we have find a current, and if we will include that in the subsequence ending at DP of J, so our length will increase by 1. That's why we are doing a plus 1 here. Okay, so now for 1 this will check 0 plus 1 1, and for this also 0 plus 1 is 1. So after traversing, our DP of current will remain 1. Okay, so that was about this iteration. Now let's move to next iteration. Our I is equals to 1, so our current will be C. So now our current is C, So we will check 2 elements before it and 2 elements after it. Okay, so first we will update it to 1, we will increase it by 1, so 0 plus 1 1. Now we will check 2 elements before it. So we have A, B, D and E. So also remember, while moving the J from current minus K to current plus K, we have to remember 2 things. First, J should be in bounds of array, and our second thing is ignore the current, as if we take the current then we will do this, we will increase 1 in the current. That does not make any sense because we only have 1 current and we have already increased it. Okay, so we will ignore that current, we will ignore current in J. Okay, so now for current is equals to C, we have increased it by 1. Now we'll go 2 neighbors before it, so dp of J, so now that is 1 plus 1 for this, 1 plus 1 for J equals to A, 1 plus 1 will give us 2, so that is greater than 1, so it will update to 2. Now rest are 0, so they won't change this 2. Now we'll move to next iteration. We have I is equals to 2. For I is equals to 2, we have F. Okay, so our current is equals to F. Now we will increase this by 1, we will increase this by 1, and we will go 2 neighbors before it. So here also we get 0 0 0 0, so they will add up to 1 and will not change this 1, so that will remain 1 only. So this will remain 1 only, this has not updated and remained 1. Now we will move to next iteration. I is equals to 3. I is equals to 3, we have G. Okay, so for G is here, so we will update it to 1, then see these values, see these elements and these elements. So if we add 1 to them, so we can clearly see that this F will give us 2, so we will increase it by 2. Now for I is equals to 4, current here was G and current here is B, we will increase our B to 1 as it was 0. Now we will check 2 neighbors before it, that is A and C and D. So 1 plus 1, this will give us 2, so our B will become 2 here, so our B will become 2. Now this will check these elements, so here we have C is equals to 2, that will again increase our element, as 2 plus 1 will be 3, so maximum will be 3. So yeah, now this 0 plus 1 won't change 3 there, so we'll move to the last iteration, that is I is equals to 5, our current will be D. As you can see, our current will be now D. So as our current is D, we will increase it by 1, and now we will check 2 elements before it and 2 elements after it. So we have 3 here, so 3 plus 1 will give us 4, so this will update by 4. This will give us 3, this won't change 4, this will give us 1, this won't change 4, this will give us 2. So we have completed all the iterations and we are left with this DP array. So now what we have to do is to return the maximum element from this DP array. So our answer will be maximum element of DP array, because as discussed, our DP array stores the length, or we should say the maximum length of subsequence ending at I. So our DP of I represents this, DP of I represents this, and when we traverse array, we have that for D we have the maximum length of 4. So we can see that if we calculate the maximum subsequence, so that will come out to be A, then A plus 2 C, so C we can include, then F will be out of bound, G would be out of bound, and yeah, we can take now B will be inbounds, and B plus 2 will be D, so we can take D also. So we have this subsequence which is ending at D and has length 4. So we can say that the DP array has a maximum element 4. So we will return 4 as our answer. Okay. So I hope you got the solution. If you want the pseudocode or the code of this problem, so I have attached the LeetCode solution link, LeetCode solution link in the solution in the description, or you can also see the first comment on the video. So because the LeetCode the YouTube is not allowing me right now to place the clickable links in the description, I am providing the links in the comments, so you can directly click and access those links from there. Okay, so that's all for this video. I know I was late today because I had an exam. Okay, so no more excuses. Bye.